We take another example, that is actually example 2, so that we can understand the concept of the application of the sequential probability ratio test. So that example is taken for the normal distribution. Let X follows the normal distribution with mean theta and variance 100. To find the sequential probability ratio test, for testing the hypothesis theta is equal to 75 versus theta 1 H1, that is theta is equal to 78, such that each of alpha and beta is approximately equal to 0.1. So in this case we have also the values of alpha and beta, and we have to perform the sequential probability ratio test for testing theta is equal to 75 versus alternative theta is equal to 78. So how we proceed? Now we write down the lambda m, which is our sequential probability ratio test statistic, that is L of theta dash m, that is the general formula, that is L double dash m. And in this case, because we know that it follows the normal distribution, for testing value under the null hypothesis, that is 75, so we can write down that is 75 m divided by the alternative hypothesis. For the alternative hypothesis we have theta is equal to 78 into m. Now we write down their respective likelihood, because the distribution follows the normal distribution, so that is actually 1 over 2 pi into sigma square, which is 100, and whole raised to power n over 2 into exponential, that is minus 1 over 2 into 100 sum xi minus 75 square divided by the likelihood based on the alternative hypothesis. This is a constant factor, so it remains as it is, 2 pi into 100 square raised to power n over 2 into exponential minus 1 over 2 into 100 sum xi minus 78 whole square. So this will going to cancel out, or after simplification we obtain the value of the lambda m, that is exponential. इसके स्केयर्स को ओपन किया गया, इसको सॉल्व किया गया, टर्म्स को इकट्ठा किया गया, तो जो नेट हमारे पास रिजल्ट आया दैट इज 6 सम xi minus 459n डिवाइड बाय दिस इज माइनस टर्म 200. जब आप इसको सिंप्लीफाई करेंगे तो यू विल ऑब्टेन this result. Now the inequalities, that is L naught less than lambda m less than L1 becomes, that is L naught less than exponential, that is minus 6 sum xi minus 459n divided by 200 less than L1. Also we know that L naught can easily be evaluated, that is alpha 1 over 1 minus alpha naught. Basically that is actually equal to alpha over 1 minus beta, that is in term of our original alpha beta, and that is in term of the new alpha naught and alpha 1, which we have already defined when we are going to explain the sequential probability ratio test. So it is given that alpha is equal to 0.1, so that is basically 0.10 divided by 1 minus 0.10, so that is actually 1 over 9. And similarly for L1, that is actually equal to 1 minus alpha over beta, and that is actually equal to 9. So hence our inequality is that is 1 over 9 less than exponential minus 6 sum x minus 459n divided by 200 less than 9. Now taking the log on both sides, we get, that is minus log 9 less than, that is 6 sum x minus 459n divided by 200 less than log of 9, or we can represent it as by solving this one for sum x. जब हम इस sum x के लिए इसको solve करेंगे तो we get that is 153 over 2 into n minus 100 over 3 log of 9 less than sum x less than 153 over 2n plus 100 over 3 log of 9. तो इसको सिंप्लीफाई जस्ट किया गया, ये जो कांस्टेंट टर्म्स हैं इनको दूसरी साइड पे ले जाया गया और सिर्फ ये इनइक्वालिटी हमने सम x के लिए निकाली है. तो यू कैन सी दैट दिस टर्म बेसिकली, दिस होल टर्म actually representing the C naught n, and this whole term basically representing the C1 n. So we continue to observe outcomes as long as C naught n is less than sum x is less than C1 n. The observations of the outcome is discontinued with the first value of n for which either we obtained C naught n is greater than sum xi or C1 n actually less than sum x. So the inequality, that is C naught n greater than sum xi, leads to accept our hypothesis, that is theta is equal to 75, and the other inequality, which is C1 n, which is less than sum xi, leads to reject h naught, that is theta is equal to 75. The power of the test, the power of that test is 0.10 when h naught is true and 0.90 when h naught is false. That is actually 0.9 when h naught is false.